So, hi everyone, welcome to this session today where we'll be discussing with Pasza, who is our innovation lead and a machine learning engineer at Appsilon, about Parquet and why it's a superior data storage format compared to CSV. So, Pasza, can you please introduce yourself a bit for our audience?
Yeah, hello. Yes, indeed, I'm Pasza, and I'm doing two things at Appsilon. First, I'm an ML engineer, and that's my background. I work on multiple machine learning projects, some data science projects as well. I work with data a lot, and recently I'm shifting to the role of innovation lead, in which I try to find new ways where we can take advantage of emerging technologies to advance our business.
All right, awesome. Thank you. So first question is, what's Parquet?
Yeah, so Parquet is a data storing format. So you are probably most familiar with the CSV format, in which you store table as columns separated by commas, usually, maybe semicolons if you're in Poland. And that's the way you store data. And for example, with images, you have JPEG format, you have GIF or GIF format, you have PNG format, and you have multiple ways of, storing the same information in some sense. But with different formats, they have different benefits and maybe some costs. And we are talking about Parquet in particular because for a very, very long time we're using just CSV formats. That's just CSV format, and we'll talk about it in a second probably. What are the benefits of CSV format and why we still keep using this? Because for some of you, it might be interesting that, well, in images, since I've started with image formats, we have the BMP format. And this is format in which we have just a single number for brightness of different pixels. And in JPEG or PNG format, we don't have this. And still we're fine with using formats in which the data is not in a, let's say, obvious form, like in BMP format, because we have some compression and other optimizations and, well, conveniences.
All right, awesome. So next question is, what are the benefits of using Parquet over CSV?
Yeah, so as I've started in the previous question, Parquet is a binary format. It's not like a text. With CSV file, one of the core benefit of using CSV file is that you can glimpse into the file, right? So you have some data, you can just go inside it and check what's the data. However, for example, if the whole file is 1 million of exactly the same rows, duplicates basically, you have to store all of them, and there is no compression involved. It's just, science. Like the CSV file is no different from text file, right? It's just we agree that, okay, we'll treat this as a comma separated values, and that's all. With Parquet, we can do some compression. And what's other important thing is that Parquet is a column-oriented format. It stores data as columns. And why it's important? Because sometimes you just want to take 3 columns out of your whole table from the file. And let's say that you have thousands of columns in a file. And if you want to take just 3 of them in CSV file, you have to read all the file sign by sign, right? You read the first line, then you see the end of the line character, so you go to the next line and so on. And you have to read the whole file just to extract 3 columns out of 1,000 columns. And here in Parquet, I know where the first column starts and ends in a file, and then where the second column starts and ends, and the same with all of them. So if I want to read 3 of them, I can just take 3 columns, and I don't even have to touch the bits on a disk that doesn't correspond to the columns I'm interested in. And probably we'll go over other benefits, but yeah, the main benefit is that files are smaller and they are faster to read, write. There are some implications regarding data integrity and possibly security, but let's go through them in a second.
Okay, all right. So how does the transition to Parquet impact legacy systems that are heavily dependent on CSV files?
Yeah, so that's a good question. There are multiple sides to this coin, you might say, So on one hand, you want to introduce Parquet only in the places where the user doesn't interfere with the data. Because as we already have said, with CSV files, you can just take a glimpse and you can see the content of the files. With Parquet, you must use some other software. But for example, Excel file is the same. Like, you cannot just read the text file for Excel, but Excel is so widespread that it's not a problem to read the Excel as a file, right? And the same, I imagine with Parquet in like 5 years, that all the tools will provide easy access to take a glimpse on Parquet files as well. But maybe coming back to the question, so let's say that you have some legacy system, and well, if it's working, then leave it as it is. It's okay, right? But maybe you see that it's slow, and then you start to measure, okay, why it's slow. And if you see that, well, it's slow because you're reading and writing a lot of data to the disk, then you might be interested in using Parquet file. Or maybe you might want to switch even to Feather, that you can read about, or we can discuss it some another time. But yeah, the one of the core benefits of Parquet is that it's a standard. And if you write a file, for example, in Python, and you write it to Parquet file, and then you want to read it in some other custom software, let's say that it's some enterprise application in C#, that's not a problem. You can just pass this Parquet file from Python to C# enterprise application, and well, it will just work.
All right. Sounds good. Okay, so are there any like notable limitations or drawbacks of Parquet that organizations should be aware of when they're transitioning systems?
Yeah, so as David Nutt said once, premature optimization is the root of all evil. And if something works, don't try to break it, right? Then one of the limitations is that you cannot just take a glimpse of the file. And for some reason, it might be a deal breaker, right? Then if user doesn't see this file, then it should be much, much easier to integrate Parquet into your data pipeline.
So what are the challenges in maintaining data consistency and integrity during the transition from CSV to Parquet?
Yeah, so maybe let's start with the data consistency in general. So if you have a CSV file and you have, let's say, 1 million of rows with 5 columns, nothing really stops you from writing 7 columns in the row number 1,000,001. And that's a huge problem, right? So you have some CSV file that you think that should be readable, but I guess that every one of you who worked for some time with data had this CSV file with some, I don't know, random number of rows to skip in the beginning because it was some kind of a metadata. Or some kind of problem with character escaping. Or maybe you had some problem like missing value. Should we have some none or missing or an A or none, like a float number none? Hard to say. And for example, pandas for a long time struggled with this. So if you wanted to have a missing value in integer column, it was changing the type of this column to float because it was using none as a missing variable.
Yeah.
And that's a huge problem because it breaks your it breaks consistency in your database or in your data structure. And Parquet, on the other hand, answers this question. So it has it uses Arrow, and Arrow has proper data types that are correctly handling missing values. And then you can have data integrity and consistency. So if you have one Parquet file and you're writing this file on your system, let's say I'm writing it down on my Mac OS from Python, and I'm reading this on Windows in some enterprise application, I know that it will be exactly the same values. I know that the system will interpret the same file in the same way. And I don't have this with CSV. With CSV, I can write one column as, let's say, integers, and then I'm reading it as floats on the other system. It might break some stuff. So in this way, Parquet is truly superior over CSV.
Okay, that makes sense. All right, so the next question is, how does Parquet handle complex data types or nested structures compared to CSV?
Well, it doesn't in some sense. So you should be aware of like CSV doesn't handle it by any means. It doesn't have any standard. You can it's all just what you agree on. And if you have nested structures, probably you don't want to use Parquet. It has some array as a field type, something like that, but you probably don't want to use this. You probably want to switch to some kind of type like JSON, and probably if you want to have data integrity, you want to use binary JSON and then validate this JSON and have binary version to have better performance. But you don't want to use Parquet for complex data types or nested structures.
Okay, that makes sense. So how does the use of Parquet align with emerging data privacy and security regulations?
Yeah, so we already touched this topic to some extent. Since Parquet with Parquet you can ensure that the data is consistent and that it has some structure. It's much easier to validate this structure, and that might help you with security regulations. With data privacy, I would say it mostly comes as around Parquet and how you handle those files. But having those files in a proper format and where you know what is the schema of this table, it's very beneficial, I believe.
Okay, right. So what are the scalability limits of Parquet, especially in the context of exponentially growing data volumes?
Yeah, okay. So there is some point in which you just want to trust, let's say, Amazon or Google or maybe some other software, maybe Databricks, with your data, and you just want to store all the things, let's say, in BigQuery. But let's say that you don't go into terabytes in one table or like tens of terabytes of data in one table, but like couple hundreds of gigabytes. So it's already a lot of data. And in such cases, you can use Parquet. And even more, you can use Parquet plus data partitioning. And by partitioning, I mean, let's imagine that you have your sales call, your sales table. And for example, you know that you have and this table is massive, let's say, it covers everything in your company. But you know that every sale has date on which it occurred. And by data partitioning, we mean that we split this whole table by month, let's say. And we will have one Parquet file for January 2024, one file for December 2023, one file for November 2023, and so on. And Parquet supports this very, very well, and it's easy to store those files then in your system. It's easy to read, for example. Let's say that you want to read only sales from September 23. So you just have to touch one file, and even more, you just want to get some of prices that you've sold things for in September 23. So you just touch this one file and you read just one column, and that's all that you have to read if you use Parquet. If you use CSV file, then you have to manually take care of this splitting, because CSV file doesn't support you here. And then you have no clue whether it was everything went okay or no. You don't have any data consistency and everything. So in this sense, data partitioning can help Parquet a lot. Once again, you have to remember that Parquet files are compressed. So even though some CSV file might be already 5 gigabytes, the same file saved as Parquet might be just 300 megabytes. So you go to the large files regime much further, one might say.
Okay, that's really cool. So can Parquet be integrated with cloud-based data platforms and services? And what are the implications for cloud storage costs?
Yeah, so you can touch this topic from many sides. On one hand, you can ask whether data breaks or let's say some machine learning platforms in Google support Parquet. Yes, they do. They all do. They encourage you to use Parquets instead of CSV files and so on. On the other hand, just as you've saved CSV files in a cloud, for example, in S3 bucket, you can store Parquet files there. And what's cool is that the same way that you can read just part of the file from the disk to extract one column, you can just download part of the file to your disk to extract one column. So let's say that you have 5 gigabytes Parquet with thousands of columns, but you know that you want to read just 2 columns. And then you don't have to download the whole 5 gigabytes file. You can just download some minor, part of the file. And that's very cool. And it can optimize your transfer costs, for example, by a quite large amount, and especially your the execution of your program or of your services.
Okay. I think you also mentioned the compression aspect of it. I think that also helps in a way.
Yeah. So the compression happens on columns based. So that's good that you've done, because you can also compress CSV file. But if you compress a CSV file, you have to download the whole compressed file and then decompress and work on it. And with Parquet, you have compression per column. And it means that, for example, I can just download one column and then decompress this column. And yeah, I don't have to care about other columns.
Okay, awesome. All right. And next question is, how does Parquet interact with other big data tools and ecosystems like Hadoop or Spark?
Seamlessly, I would say. Hadoop really like this idea of data partitioning, and it works with Parquet very, very well. The same with Spark. But I would like to really stress it that while when we say about Hadoop, we think about tens of hundreds of gigabytes of files, and then we want to use this kind of machinery to analyze our data. And Parquet can work in this regime, but it also really helps you in like normal data regime, so just a few megabytes, because it's I cannot stress this enough. It's very beneficial and makes your life much easier if you just save one file in one program to Parquet file, and you're sure that your colleagues at work or your friends or whoever will download this file and they will read the exact same values. They will not have to fight with, oh, what is the quoting of this CSV file, what is the separator, and so on. That's, I believe, the main benefit of Parquet. But with big data platforms like Hadoop, it works perfectly.
Okay, and that wraps up the questions that we have listed. But I do have a question of my own. So as someone who, because as a beginner, you're mostly exposed to CSV files. So for someone who wants to learn how to use Parquet, like where can they find resources or a test data set they can use to like try and build something or do some data analysis or manipulation with a Parquet file? Because mostly it's CSV that's available.
Yeah, sure. So, you know, all the libraries that you probably use, like Pandas, dplyr, Polar, StackDB, they all support Parquet already. I really encourage you to read a post on our blog, on Appsilon's blog, CSV to Parquet transition, or common folks use Parquet. And then you will understand, okay, so what really I can do with Parquet files. And if you want to play around and you wonder, okay, but where can I find some Parquet data set? Just use your CSV data set and save it as Parquet from Pandas, Polar's, dplyr. And then you can check, okay, how much faster it read from the disk or wrote to the disk, or how much smaller or larger is file, depending on the format, and whether indeed I can read just a few columns. I don't have to read the whole file. I really encourage you to play around.
Okay, awesome. Thank you so much, Pasza, and thank you everyone for listening. If you'd like to learn more about this topic, you can check out our blog post, as Pasza mentioned earlier, at appsilon.com. The article specifically for this is Common Folks Use Parquet, and we'll see you in our next session.
Thank you, Gigi. Thank you. Bye-bye.
Thank you. Bye.